C'est bien fait quand même. Oh,
Hey, c'est en train de
oui,
recorder. Segmentation of anything. So the main advantage of Dragonfly, well, it's very diverse. It's a big tool. There's a lot of quantitative tool in it, and also very advanced deep learning segmentation. But what's most important for most of you in the room is that it's free for non-commercial. So you can use it as much as you wish on Linux and on Windows. We're adding new feature all the time, and we're open for collaboration. Also, we're collaborating with multiple universities on different aspects of the software, and the software is kind of open. Also, you can put your own code in it. There's we have a framework for you to inject your code if you're coding, or you know someone that wants to include filters or functionality. It's all written in Python and C++, and about 90% of the code is accessible. In fact, and you can look at it. There's only small part that are obfuscated, and so if you wish to do something, you can look at how we do it and copy and modify it as you wish. You know, so there's not a lot of software that is accessible like that. You know, because we're a commercial company, it's quite unusual to have open access to the code. But we prefer to do it like that so that people can easily integrate new functionality in Dragonfly. So I will start by, today I will show mostly the basic up to segmentation tool, 2D, 3D segmentation tool that you need to use anyway to provide data set, training set for your deep learning or whatever advanced segmentation that you do. So it's important that people understand, see all the capability of the drawing tool. And I will talk about also all the object model that you can deal with. So data set of different type like byte, short, int, float, also meshes, region of interest of two kinds, multi-ROI, which is a multicolor, exclusive, auto-exclusive region of interest, single ROI, which is like a binary segmentation, graphs to collapse. Let's say that you want to deal with a porous network. It's sometimes useful to collapse the representation to a graph-like representation and be able to do search like distra search and stuff like that to compute the tortuosity, and vector field to represent the vectorial data. So this. Oh, okay. Sorry. It's a bit, yeah, it's strange because when I close my sound, the sound continues to on my side. It's weird. Okay, so I will share now my screen, and yeah. So you see here in the background an example of a segmentation, which is a FIBSEM of a retina cell. As you see, it's totally segmented: nucleus, mitochondria, ER, and some processes or something like that they call. There was like, I think, 11 type of organelles segmented. It's an image from DC Lab in the US. So I will start back. Oh, it's a color stack. The image? Strange. Okay. So I will start back by the basics. So I will give you a crash course on how to load data and stuff like that. I know that some people know Dragonfly already quite well, maybe redundant, but I will try to cover stuff that you may not know. So I can open a folder, I can add files. Here I have the, whoops. Sorry about that. Should not show you all of that. Okay, so here I will load the 8-bit, oh, they were stored in JPEG, funny. Okay, I will load our data set from Ixon. Okay, it's a JPEG. We support, as you see, multiple formats. What is that? Yeah, we support TIFF, JPEG, RAW, PNG, PIC, multiple format. And here it was stored as a JPEG. In that case, it's a tone of gray image stored as a JPEG. It's useless to have it like that. I will just take one. Yeah.
Sorry, I just want to ask questions.
Yeah. Okay. No. Okay. I should have tell you that. Sorry, I am a bit still jet lagged, so I'm not totally synced to the time zone of France. So feel free to raise your hand and ask questions. I will try to answer them directly. I will repeat the question so that the people online understand the question, and I will try to answer that. Okay.
So I have a question about file formats. I was wondering some of the new file formats, like the some of phrases coming out. Do you guys have plans to integrate more file formats, or do you want us to continue doing it?
Okay, the question is about new file format support and what are our workforce that we're putting on that. We're trying to support the most format that we can, the most format that we can support. Of course, we cannot support everything in every direction. There's a lot of really few user type of format, but we have a system where you have a hierarchy of classes where you can put your own code to have your own format. And if you, let's say, something driven that ImageIO is able to load, it's very easy to include. But if you want, you can put your own library to load, and it's a system so that you just provide the code to load. It will be available on the loader afterward, and you will be able to load your own format. You could do a specialized reader for your own very special format if you wish. So here I can do sampling at the loading, so I can jump over value without binning. So I can skip voxel at load time. Here I have it's not a time series. I can specify the spacing in each dimension. Obviously, in that case, it's a JPEG. There was no properly encoded spacing, it seems. And I can flip the data in any sense. And something that is important also to know is that you can crop at loading, of course. So you go to a slice where you cut something, and you can use this this tool to crop and select subpart of the data set that you want to load, of course. Another thing that is important that I will show later is that you can apply the same cropping to another data set that would be at the same position. Let's say that you have done an acquisition on a FIB SEM or on a SEM, and you have multiple channel, you can crop multiple image the same section, so you don't need to go back and choose another section and remember what were the index of cropping. You will just do the same process on multiple stack of image. Maybe not so relevant for yeah.
Just the image sampling, it's not binning, right?
It's not. It's a jumping sampling. This is for the loading, but there's multiple ways in the software to downscale the bit depth in linear, cubic, nearest, or tricubic, or even random if you need so, which is kind of, I'll talk about that later. So, okay, now since it was encoded as a JPEG 3-channel, which is it's crazy because it is a tone of gray image. I just take the luminance, which will be calculated on the fly. It will be the norm of the vector, which, since all the components have the same value, it will work. So now I have my Lego man loaded. I see it in the acquisition plane. So first I will say that text that change, object on screen that change color like that mean that they are interactive. So here I can move the lookup table. I can change also the scale. I think not in that format. It's a scale burn in the image. Sorry. So show scale bar. The scale bar that we have can be moved. Of course, as you see, the scale bar is in a strange unit because the data is not calibrated at all. So here, this text says what is the size of the red window that you see. In fact, this is the actual size, and it serves as zoom. If I click on it, you switch to the zoom mode. Down here, you see the state you are in. You are always in one of the state. The state button are all gray, so you switch state like that. And notice this is track. It's for when you have multi-planar view, multiple region, and you move the cursor, or I will show you that later. But the other one, let's say the zoom. When I click on that, I switch to zoom. As you see, the button is automatically click. And it's a temporary mode. I go back when I remove my mouse, my left click to the previous mode. If I was in pan, I click on that, I will go back to pan. So there's multiple shortcuts for each of the state. It's easy to get lost a bit. So the trick is to use the button at first. Here, the range, okay, it's related to the histogram representation of the data. So it's what we see, and there's multiple ways to saturate the image, okay? But I will cover that tool a bit later. The slice is to go between slices. Yacht pitch rolls, for those that know how to drive a plane, it's very intuitive, but for us, normal human, it's not so much, but it's a way to change the orientation of the plane that you're looking at, because of course our software is capable of oblique view on data, okay? So if I switch it back, this is the button that magically make everything go straight afterwards so that you're not lost. This also put the current object on screen on the view. So here the modes are simple. Track, it's when you have multiple views. Okay, don't hesitate to ask questions. I know it's very basic now, but I have to cover that for the people that don't know much. So about Dragonfly. So here you have the spacing is very weird. It was not well. I will take a data set that is less skewed.
Oh, asking that if you realize you've done that wrong, how can you go back and reset your dimensionality?
Yeah, of course. Yeah. The question was, can I change the spacing or the orientation of the data set after I've loaded? Yes, of course. We'll show you that a bit later. So I will load the data set and I will ask who can guess what we're looking at. So I load a stack of TIFF. And now the dimensionality was good. So it's a 3.64 micron data set. It was taken on the Xradia machine at McGill University by me, in fact. And yeah, so it's not a very big data set, 16-bit. It's loading it now. Okay. So usually when I'm in Canada in a class full of students, I say I will give $5 to the one who guess what it is, but I won't do that here. It would be inappropriate and not just for the people online. So in fact, it's salt and sugar. I had access to the scan. I didn't have a lot of stuff to scan. So anything that I could put my hand on, I put on in the scan. So, and it will be a good example for multiple tools that we will present. So this is for panning. And when we talk about panning, we're talking about moving the camera, not the object, of course, because each object has their position in space and our software is fully correlative. We come from medical space before, and when you load the AMR, for instances, you can have very different orientation, but you want to merge them in space. And in the laboratory, they have defined a zero position, and everything, when you load it, jump into the other when you're doing multiple sagittal, coronal, or oblique acquisition. So when these buttons change only the camera position or distance or that kind of stuff. This is the slice mode, which is equivalent to click on this one. This is the zoom mode. Okay, this one is more amusing. It's a walk mode that we call. If I put myself, let's say, on that grain, I can tilt the view and rotate about that grain, keeping that at the center. Where I've clicked is the center of rotation, and I can tilt in any direction. Sometimes it's practical to follow a crack, a vessel, or something like that, you know, when you're tracking something. This is for changing the pivot of the 3D view, not very useful here. So I will, since I've been talking about view, I will talk about the cursor here, which is important. And the mode,
Can I ask you, Nicolas, just the shortcuts for panning and zooming for the with the mouse?
Okay, so the mouse
very
has
useful.
a shortcut also. So the question was, well, talk about the shortcut that you have on the mouse. So if I click left and right button, I switch automatically to pan. If I click on the middle button, I switch to zoom. If I use the mouse wheel, I change the slice. And there's other that I don't remember. Spacebar is to switch to leveling, to change the brightness contrast, okay? But there's tons of other, and in fact, all of that, and it's kind of intense, but I will show you. In the preferences, you can change the language. Now we're in English, but you have access to all of those languages. If you want to learn Chinese, it's a good trick to do. But usually I don't switch to Chinese because it's kind of tough, you know. But in the configurable action, it's all the control of the software are totally abstractified, and you can change the key that you need to do all the action. And there's some, as you see, there's a couple of them. If one thing that you should know that is a good thing to know, sometimes we broke that by ourselves. You change the configuration and nothing worked, or something worked very bad. You can do restore to default. And this is very practical because the action, it's very complex. It's a control of the machine state of the software. But it's fun to be able to configure it because some people have very strange keyboard or additional keys that they want to pad to certain function, and you become more efficient if you're able to do that kind of manipulation. I will go back to the preference later. We'll continue on the view. Notice that when I click escape, gives you back the default state also. Sometimes you're lost, you just press escape and you will go back to track. Track mode is the mode to interact with object on screen and also to be able to move that cursor. Okay, it's not super visible. I will try to enhance the size of the cursor. Just a second. This line cursor. Okay, everything is in screen percentage, so I could, let's say, triple it. Okay, now it's more visible. Okay, so notice each screen, when the current screen is the screen that is in red, okay, or the view if you wish. The view is like a cut plane that cut your data in space, okay? And you can have multiple data at the same time at the same place, and you will see them in fusion mode, and you can control the opacity. But I will cover that later when I do correlative stuff. But now what you need to know is that the current one is the red one. 2D setting will appear when you have a 2D view visible, and 3D setting will appear when you have a 3D view visible, okay? So you have always, like here on the side, you see that this is very annoying. I will try to hide it. Yeah, okay. So here I can control, I have here my data set. You see, I have only 2D setting accessible for this view. And when I switch to that one, I have 3D setting for the rendering. And there's, I could talk about rendering and how to fiddle with the color and the shininess and all that for multiple hours. We'll see if it pleases people to know that, but I want to cover the basic now. So here you can, the 2D setting accessible is you change the interpolation of the view. But I was about to talk about the windows that we see here. So you see when there's a little red line on top of this view, a little blue line on top of this one, and a little green line on top of this one. These views are represented by the line here. So the green line is that view, the intersection of that view in space. So if I go overing on it, I can modify the position of the Y view clicking on this one. The same with this one, and all of them, it's the same. Sorry, my mouse is a bit new. So sorry about that. This is weird. Okay, so I can change like that. Also, when something that is practical, when you double click on a view, it maximizes. Double click again, it minimizes. Okay. If I click on the middle of the cursor, I put the tree view at the position I specified there. Okay. If I select one like this, you see that there's a little triangle that appears. This is to change the oblicity of the associated view with the line on screen. Everybody is following me. I know I'm going a bit fast and I have tendency of jumping a bit too much. So here I can do that. I have put my green view in an oblique and I could choose to orthogonalize the other one. Whoop. So if I right click on that view, I could say the two other view, I want them orthogonal to that view. Okay. So it's a way to position yourself in space and align yourself to the sample, because this sample is well behaved and well oriented in space. I mean, the cylinder is in the C direction. It was well taken and all that, but it's not always the case. Sometimes you put an oblique to reduce like beam artifact or whatever, and you want to reformat your view in that view, in that angle. And we have everything needed to be able to derive a series. The concept of derivation of series is the name they use in medical. But in fact, when I talk about deriving a series, creating a new data set from a different angle. Okay. So now we're okay with that. We know how to move around on screen like that. Here, those buttons, as you see, are action buttons. They are not state buttons. It's just for the current selected view. I want to flip the camera, X, Y, flip, or rotate like that. But it's, again, just the view that I'm rotating. If I click on reset here, I reset everything. Okay, now let's cover a bit about what we see on screen. Okay, so if I maximize that, here, this is the function transfer function system to play with the brightness, contrast, and gamma of the views. Okay, so here I can take the range and change it directly. Okay, but it's equivalent to changing the range here when I do that. Okay, so I'm going back and forth, and it changed the position and the width of that. So when I go back and forth, up and down, I'm going back left to right, and when I'm going left to right, I'm increasing the range of what I want to see. Okay. Also, well, there's reset here, and there's a reset somewhere else here. Okay. This is all good, but often you want to put color on screen and different color for 2D and 3D. Let's say that you want to do color for 2D. You can access multiple lookup table, and you could also build your own or flip the color table and all that. It's all easy to do it here. So that's it. I select the jet color. Okay, I can move those little blocks and create a new ramp and change the color range based on the stuff here. So you can, if I use my mouse, I'm zooming in the histogram, I can pan it and move it around, and I can change the color ramp and make it in between on the complete, the color ramp apply complete on the range or on the complete data set, on the range of the data or the selected range. So relative or absolute. Playing with color is kind of tricky to get the good one, and it's like that in most of the software because it's a complex object. Also, yeah, this is relative, absolute, and I have different type of transfer function. So here you see that the ramp, the alpha of the image is modulated by the opacity of the image is modulated by a linear ramp. I can also have an editable opacity, so I can change. This is a bit weird. I can change some opacity region and change the very minute change on the rendering. If I go back, okay, and I switch back to, let's say, grayscale, just to have something more digestible. You can also play with the gamma. If you have a ramp like that, the transfer function, you can enhance the value with gamma. A gamma filter is sometimes interesting to show better the contrast. Okay, sometimes it's very tough to optimize the contrast for a certain region of the images. We have a tool for that, this one. Okay, you select this, it's the area Windows leveling we call, And if I want to optimize the contrast for that region, I do it like that. So now I have full contrast in that region. I see nothing else. If I do it like this, I see that. And as you see, depending on what I select, I enhance different part of the signal. It's equivalent to taking that and moving it, okay? But it's more intuitive. You look at the object, you want to enhance and see the detail of the tone of green in that region, you do that. Okay. So let's continue. This is for the 2D. If I go to 3D, it's always a different set. Sorry. It's always a different set of setting for 3D than for 2D, because 2D and 3D, they don't behave the same in rendering. If I go in the rendering here, okay, I can change multiple stuff. I can have, I can put lighting and all that, but just talking about the rendering, you see that you have much more mode that you can use for the transfer function, the opacity, because it's much more relevant in 3D, in fact, okay? So you have band pass, you can have free floating, you can change the opacity. You want the opacity to saturate or not, or not saturate at all, so that it goes to 0 after at the end, or it's blocked at the end. There's multiple modes, and I would say that you need to test it by yourself on your own data to be able to understand the subtlety, and it's very data dependent. So here, let's say that I want to see only the bright, I suppose, sugar. I'm not sure, in fact. I just do like that. You see here, I have no fancy lighting or whatever, okay? And it's even linear interpolation. The interpolation, when my data set, I can control the interpolation here, okay? Cubic interpolation, I can do some filtering, I can enhance the quality, it will push more data, less downgraded data, and I could do lighting also, that I will show later. So this is about 3D rendering. There's multiple settings for that, and I will show you later how to crop and all that. Okay, so Windows leveling is a complex tool. You can have multiple of them, each for 2D, for 3D, for all the data set, because each coloring and opacity setting are per data set, and you can have multiple data sets. Yes?
Is any trend for
You can create a lookup table and apply it to the other one, but besides that, there's not a lot of correspondence, because the volume rendering is another technique, quite different technique of showing the value on screen. When I'm doing 2D here, okay, the data is cut in the data matrix, and we interpolate in nearest cubic or linear, and we present exactly what we show, and we apply the transfer function. There's no integration rays and all that. That is like that you deal very differently for showing or highlighting part of the image. Something that may be of interest to you, and it needs to be understood, I suppose, is that you see this image is presented in a 3 cubic interpolation here. We cut the volume in a cubic on a plane, and we interpolate. The plane can be any oblique. So if I switch the oblique, okay, and now I'm looking at the data in an angle, it's not the same. There's no, we're crossing multiple row and column of data, and we're cutting in diagonal the data. It's all interpolated. If I put my view in nearest, I can look at what's really happening. So you see that we can even have, if I switch like that, I can have triangle voxels, in fact, but they are not we present the data at the resolution of the screen. So this is a voxel that is present in the data set. I'm presenting it with, let's say, 50 pixel on screen by 50 pixel on screen, but I'm truly cutting the data. A lot of software do it differently. So, but this enables us to have exactly we see all the voxels that are cut by the plane, even those triangle one, the little triangle like this one. So you see, there's no hole in the data. That's what I wanted to see. Okay, yeah.
But nevertheless, if you are happy with some settings that you've taken on one of them, you want to propagate this to other users one point or another, is this kind of
Well, you can, I need to think about it, but you can save the lookup table, and the range that you put, you will need to, no, there's no easy way to do it, but it's a good suggestion. I will take note of that. It makes sense to be able to do that. Okay, I'll go back to a few, I guess. So since we have to cover a lot of stuff, I won't dig too much in this, because I could continue a long time, because here it's all in tone of gray, but it's from 0 to, it's a short data. Here you have information on the data set itself. Okay, so if I look in that detail, when I select the objects are shown here. This is the data set. When I'm selecting it, I see the width, height, depth, time step, size, and type of data also. Okay. So, but this data is not calibrated. Sometimes you want to calibrate to say that it's a physical unit, and you know that tone of gray, I don't know, something mean that number, atomic number, or density, or whatever. You can apply a linear transform to your data. So when you click on screen, you know that, well, this is, you've put acidity or temperature, or whatever, you can apply a transfer function to spatialize, to make a, to give a real physical unit to your data. Okay, so now I will cover the annotation tools, which are very practical. But to show that a bit more, I will open a new data set and show a bit of correlative imaging. So if I go on my test. Oh, no. Okay. Sorry. Yeah, here. Point. Okay. This is an acquisition done on an Extradia machine again, and you have two data sets. We have the full body, okay. And if I go there and then change a bit, so it's a mite, okay. Quite a nice scan of a mite. And we have also the head of the mite at higher resolution. Here. So if I put color there, you'll see, or a different preset, let's say plastic. Oh no, not this one. Sorry. Okay. I could say I hide this one, and you see that you have a higher resolution. The head now is in yellow. If I go back to 2D, and I put myself in the head area, somewhere like that. Okay, and I'm in full screen, and I zoom at that place, and let's say the head. I open the clip box, yeah, put myself in the middle of the head. Okay, you see that there's a change of resolution, and if I put this in nearest and the other one also in nearest, it will be more apparent. But and I put the head on top so that it's the last one render, you see that there's a difference of resolution, of course. So the head is scanned at much higher resolution than the rest. Okay, it's the segment. The registration is quite good, but later on I will show how to enhance to increase the quality of the registration. But now I wanted to talk about annotation. We have point annotation to specify point. You can put point on screen. Okay, up control, and you have different points. You can put caption on each of them, whatever, and it will appear on screen, and you can move them after you just click on it and move them. It has the position and the gray value of the data set also, I think. Yeah, of the two data set there. What is often this is kind of, it's a tool that point annotation is to show something on screen to someone, but it's not, it's also a tool that we use for other tools to add point and do a calculation, or RBF or plane or something like that. So it's a tool by it's a useful annotation by itself, but it's an annotation that we use in multiple other plugins. Okay, I didn't talk about nomenclature. All these are plugins. Okay, all those little panel are plugins and are represented as directory in the code. You can even look into that and look at how we do that. But if you were to build a plugin, it could appear like that or as a floating window also. Now I will talk about the ruler. Okay, if I draw a ruler like that, I have the measurement. I can change the ruler style in multiple ways. I can project so that it's like this, and I can play with the rendering of the ruler. But something that I want to show you that is interesting and talks about a correlative workflow is that I can extract profile of the data. Okay, and now, and the color is not very clear, I will enhance the contrast. Let's say this one and this one. So these are the tone of gray on the line that are coming from each of the data set. Okay, so I can do some integration. I can say the number of points I'm taking on the ruler, but I can say also that it's a point or it's a disk. So it's a normal disk, in fact, of integration. I can specify the size of the disk to do a mean value on that. So let's say that I select the disk and I increase it I don't know. I'm on micron scale now, but I could say 0.1. Yeah. So now I've made it so smoother. And here you see the high resolution and the low resolution data set on top of each other. And we can kind of guess that they are not totally perfectly aligned looking at that. All those graphs are in matplotlib and are exportable as EPS directly to put in your publication. There's some feature you can configure them like you do when you do matplotlib in Python. So there's you can manage to have something that it's quite presentable. If I move there's multiple ways to move a ruler. As you see, I can highlight the control point only and pivot the ruler on the other one, or I can drag it. And as you see, the values shown on the graph are updated automatically. So the ruler is a quite good tool often to introspect a bit about the data, to understand what we're doing and how it is, what is the shape of the edge of the data set. So often you should not believe your eyes. We have a lot of neurons doing like adaptive contrast enhancement in our eyes, and sometimes you think that it's I have multiple examples of data set where you think a region is brighter than another one, but in fact it's totally wrong, and it's built in our brain. We cannot turn it off. So you need to be able to introspect the data like that, to play with the to understand the shape of the tone.
Nicolas, can you maybe demonstrate again where to get the line profile? Somebody was asking that.
Of course. So the line profile is here. I have drawn a ruler, okay, and I can draw the ruler in any oblique. I will do it just to demonstrate that it's possible. So I will switch to a very strange oblique here, okay. So we're looking at the data set in a very strange angle, and I will draw a ruler going from there to there. And I will ask, the blue button here is the one to extract the line profile. And you could also extract this histogram of the data along the line also. Okay, so I extract the line, and now I see what I've shown earlier. So it's an intensity profile, and you see both data set overlap. You can change the scale and have an adaptive scale and all. But in that case, they are all well-behaved histogram, but sometimes you mix like float plus int or short, and the scale are very different. So you can play with an adaptive scale and that kind of stuff. So very practical tool. I use it often to understand the data. Of course, we have the other basic measurement to do an angle calculation, Cobe angle. They tell in medical, it's to evaluate the parallelism of two faces or something. Of course, we can have a path, okay, and I can draw and modify the position, and of course, I can extract also the profile on the path to see what we're looking at in the path space. The path has multiple functions. You can resample it, you can close it, you can smooth it also. So you can make so that the path is much smoother. So I can apply smoothing on the path like that, and it will become like a line at a point. So this.
I have another question from online. I think it's useful.
Yeah.
Can you use the line profile to align the two data sets and fine tune it?
Yeah.
And at the same time, please show the opacity for that
For each of the data sets. Yeah, it makes sense to talk about that. Okay. So I will start with the opacity, and for that, I will just go back to a proper view. Here, you see, we have two data sets. The one on top is the last one to be drawn, okay? So when at first it was like that, okay, and you can drag and drop the order here, okay? And since they are fully opaque in each of one, you don't see what's underneath, of course. If I put the head on top, it will appear on top. Sometimes I want it to be of different color, okay? So I go to Windows leveling, and even I can click here and change the color ramp, okay? And put it as a jet, let's say, or cool or whatever. And now I have the color only for that one. And also I can change the opacity. And this is practical sometimes to see what's underneath, okay? It's very often practical. There's no limit on the number of layers that you can put. It can be 20 images on top of each other. Of course, the opacity is kind of hard to manage when you have 20 data sets, but it's quite unusual to have more than, let's say, people in confocal microscopy, sometimes up to 7, rarely more than that, you know. So I never saw someone with more than 7 channels to put on of the same object at the same place to put on top of each other. Well, the question was about registration, okay? And I was just about to go to the translate rotate is the plugin just besides that one. So if I put a ruler, okay, like this, and I put it on the, let's say, on that edge, okay? So I'm supposed to see this part, the shell or exoskeleton of the mite at different resolution. If I ask for the profile, and I change again the default color because I'm not able to see them properly, and go like that, okay. You notice that when I change the position of the ruler, the profile change accordingly. If I click on this button, okay, it will move the selected object. So I switch to move rotate mode of the selection. I can move multiple objects at the same time. If you have a referential with a ruler on a data set and you want to transport it to another place, you use that tool. So now I have the profile, and I am also in the move, translate, rotate state, okay? So now I can take that object, that widget, and drag it, and it will move my data set on screen, okay? So now I could align or try to align the profile like that. Also, I can use the mouse wheel, the keyboard arrow to move more precisely. The precision of the movement is related to the zoom factor in a sense. So if I go, now I'm not moving the camera, I'm truly moving the object in space. I'm changing the position orientation maybe of the object now. So there's a lot of update because this is open. Usually you don't do that, but it's okay. So now I will zoom to have more precision, okay? So I will just close that one for now. Change the opacity of this one so that we clearly see what's underneath. Okay, better see what's underneath. And now using that tool, I can move it like this and use the arrow key on the keyboard to move it with more precision. Of course, this is when you cannot do or you want to start an automatic registration, because it can be difficult to register complex object, even more if it's different modality and you're a city on AMR and all that. It may be different to see the correspondence of tone of gray, and the mutual information is much better than us to find the correspondence. Okay, so I'm moving like that, and I can rotate. Also, I can change the pivot position and rotate the object as I wish. Of course, we're doing it in real space coordinate. And when I'm moving the object here, when I go back to that mode, I can see that I'm moving the object in space also in 3D. Okay. There's an undo button that is very handy here, okay, because sometimes it's difficult to understand what you went too far or something like that. And yeah, so you can do rotation translation in any axis and on any oblique also, which kind of become quite difficult to understand when you think about it a bit, what you're doing. So you put your, yeah. Yeah, the rotation matrix stack is saved in. Okay, the question was, can we save the rotation and position and all that? The transformation that you're doing, each transformation step is a new matrix in a stack of matrices, and you could apply the same transformation to another object. Okay, if you have forgot to multi-select, because if I multi-select object like the ruler and the data set here, and I do the movement, both are moving at the same time. I can do that with any type of object, 3D or 2D object and all that, I can move them. But the transformation stack is there for you, and you can of course undo it or apply it to something else. One thing that is related to rotation and all that is how, and related to the question that was asked earlier, how can I verify, modify the spacing or something that was wrongly input? If you right click on a data set or a region of interest, you can do image properties. And now you see the size, the position, the unit. Okay, we have a system of unit for calibration for deep learning, and the slope and offset related to the unit, the spacing, and also the direction vector of the box and the position of the object in space. So you have everything to understand where the object is in space. And if you save it afterward in a format that support positioning, it will have the positioning with it. There's not a lot of format that support that. DICOM does, or our own format. TIFF does not support orientation, although it supports spacing properly. So some people hide those information in proprietary format, like in CZI, they may have included something to code it, but it's not super common. So on other software, you would have problem doing it. So I will go back and go back to my original position and all that. So let's say that I will go and reset my view, put everything in the, okay. When I do, this button is fit to view. I have the head selected, it fit the head. If I select the body, it will fit the body, okay? So you decide what you want to put in front, how to use your real estate in your view. The selected object is wrapped with a box in the 3D space. And if you have multiple objects, it will do the enclosing box and show it to you on the screen. Okay, next annotation. We have done the path, and okay, path I didn't finish what you can do with path, and there's a lot of strange things that you can do with the path, and maybe it's not super relevant, but let's say that I managed to put the path on the shell of that guy. If I right click on it, I can export a data set normal to the path. It's like vessel extraction, okay? So it will generate a new data set, okay, with, let's say, 100 voxel that is a normal extraction along the path. So let's say that you have followed a vessel or a track or something, and you want to stretch it out, okay, this is the way to do it. Sometimes it's good. Let's say that you're working on core sample of wormhole, okay, and you want to straighten it to understand all the branching and stuff are happening, well, this is a way to do it. But of course, the correspondence in space is not so good. So if I could show that data set and show you how it looked now, and for that, I need to reset the view. And now in the axial view, I'm looking at the data as view from the path as I was in a buggy running on the path, you know? So that's what I would see. In medical software, often they have an additional function, which is a curve planar reformat that we don't have yet. We used to have, but it's kind of not very useful in your field. Okay, so I will go back to those two guys. So arrows are an annotation tool just to show something, okay, and put caption so that you say this is a really cool feature and take a picture. By the way, about picture, the button, there's a little camera here, okay? If I drag and drop, it will do a picture at the resolution of the screen. So if I maximize, it will do it at something like 1200 by 960 on my machine. I just press like that. If I press on it, it goes to the clipboard. If I drag and drop, it generates a file. And if I want a bigger picture, I can go up to 20,000 by 20,000. If you want to do a poster that cover the full conference, it's possible because 20,000 is kind of big, you know. So it's very unusual to need that kind of resolution, but it's totally possible. Our deal is what you see on screen will be on the poster. Yes. No, there's. Okay. It depends on, okay, so the 3D, there's a limitation that comes from the graphic card themselves and the question was about resolution of output screenshot. The maximum for a 3D screenshot, I think it's 5,000, and the maximum for a 2D screenshot is close to 20,000 by 20,000. I'll show you a bit later how to do that. And of course, everything that you position on screen, okay, like the lookup table that you can. Whoops, I'm on the arrow mode. I generate an arrow for nothing. So I will press escape to switch to the track mode, and I will destroy the arrow I just constructed, which is annoying. So if I select an object, is lookup table. Oops, sorry, didn't work because of this tool. Yeah, like that. Okay, so sorry. So when I'm, what I was about to say, sorry. So when you select the object, the feature that comes with it is shown on screen. So here you see the legend for the wide field of view. This is the legend, the lookup table for, and the value for the head. And if I select both, you should see both. Okay, and if you have 10 data sets, you can show all of them. You can switch them for vertical, horizontal, and stuff like that. So you can prepare a picture that is quite pretty. Press on the button, and you have what you need. Hopefully, what you need. Okay, so I've covered the ruler, all these one, and now we're going to 2D region. Some people, well, they call it. Yeah, it's 2D region. There's multiple ways to talk about that, but let's say that I'm measuring something rectangular like that. Okay, I have this is the area or the perimeter, I mean, and you have the area noted here. Okay, so you can modify the shape, move it, and all that, and you can also extract histogram out of it. So this is the histogram of the full body head of view of that portion of the data. Okay, of course. As before, I can be in any oblique. Okay.
Nicolas, there's one question from the audience here. Just
oh.
Can you change the text size on the legends?
On the what?
on the legends.
Yeah.
Changing text size on legends.
Okay, the legend. There's a lot of. Let's see that if I click on the legend, right click on the legend, you can change vertical, horizontal, but if you go to preferences, there's font, all the font are described, and you can change the font of the annotation. Not specifically this one, but it's a good point. We should add that. you know, we're always happy to have criticism. And in fact, I always tell people, don't tell me that my software is good, tell me what is bad about it, okay? Because I don't care about what is good. I want to know what is bad to fix it. It's important for us to understand that. I hope you find it good sometime, but and bad most never. But anyway, I'm sure that there's some glitch and there's some bugs. It's a big software. There are 3.5 million line of code. There's tons. I can do a teaching for a week and not cover everything, you know. And there's some good space for improvement.
But okay, so there's one more question from online. Where can we find the transformation matrix? Is it exportable? I think
the stack of transformation matrix. It's not. I need to think. I will come back to that question. You can export the box. I could write a snippet of code in Python that do it in 5 minutes, but there's other ways to, I suppose, to export the transformation matrix. It's stored in the object, so you can go back to your previous stack of matrices, but you cannot go forward, only go back. So there's a lack of functionality at that point. But usually what you want is to see the final transformation. And for that, you can export the box orientation and positioning and extract, and you can ask from the object, what is how it was modified from the beginning. And it will show you how translation and rotation was applied to it. Yeah, I was about to show that you can do a histogram in any object, okay, and it will work, and you can switch between different data set. And oh yeah, because I have I will remove the extracted, yeah, and you can change of course, the density of the histogram and all that. Yeah, in the next version that will happen, be available in September, you have a system where you can plot the median, the mean, the 5% and all that of your histogram to understand better the histogram. And also you can add your own measurement in the histogram to have like specific measurement. Like we were working on BMD, bone mineral density, automatic measurement position on the histogram. So it will be available for September, but it's a system that can be enhanced by any user, in fact. Just to say also a detail about the presentation, we'll take a bio break for humans around in 30 minutes or something like that. So
I think there was a question here from, did you have a question? Oh, okay.
But don't be shy. Ask question. I like that. Okay. Okay, you have, yeah?
Just one simple question. You told us how that you can actually save the screen, but once you have repositioned your viewing space, can you actually save, for instance, a stack or a new stack onto this orientation?
Yeah. Derive a series from that orientation. Yeah. So this is very easy and very common. Let's say that you prefer that orientation for your data set, okay? I don't know why, but let's say that it's true. So you can click on it and say, derive new from current view, okay? So now it will generate a data set of the head, okay, the one I have selected, along that view. So it will generate the enclosing rectangle that will be like this and derive it on that way. So when I highlight it now, okay, well, it's there, you know, and it's exactly at the same position, but the orientation of the box, if I go and whoop, I show it in 3D also, and to prove that they have not the same orientation, okay, I will go back and open the clip box around them. So this one has a clip box oriented like that, and this one, the original one, has a clip box oriented like this, okay? So you can easily do that kind of transformation. And there's multiple other ways to derive series, not only with the view. You can use a box, in fact, that you position in space as you wish and extract the data set at the frequency that you wish with the three type of interpolation: nearest, linear, or cubic. Okay. The other annotation are practical there, but anyway, a circle, anybody knows, well, an ellipse, a circle, this one is practical often, And it's a very simple way of generating a circle that we see in medical, but are not usually done in many software. It's a 3-point circle like that. Okay. So and when so you find 3 spots on your feature, and it will fit a circle. Okay. So you have also multi-point like this, and a free tool like that, where you can also extract, from which you can also extract the histogram, of course. Okay. And when we do the histogram, I think in that case we do a linear interpolation of the data in the plane and all that. It's kind of, well, when you're in oblique and all that, it seems simple. It's not rocket science, but it's like 40,000 lines of code just to play with the views and all that, and slice it in different axes. Yeah.
When you make such a shift, can you perfectly dimension from the histogram?
No, but in fact, what you can do is to chop the data set in 3D and make a region of interest that is a cone based on that. If you're in perspective, it will be something conic. If you put yourself here in orthographic projection, it will do a perfect cylinder. No, but it's a good. It's a good point. In fact, here in the, and I will take note, or could you take note, please? So in the histogram, we should have a feature here to say the thickness. Good idea. I will do it. It's not, we have everything to do it. It's just that we didn't have someone ask us that question, which is a good one, I suppose. Yeah. Yeah. Yeah, well, that's what I showed earlier, but I was going too fast, I suppose. So if I draw a line like that, okay, and I go to profile, now I have 2 data sets, okay, and here I can say I'm doing a point interpolation now. I can do a disk or a square. The square will be aligned with the view, I think. Yeah, and you can specify the frequency of point on the line, okay, so to see more detail, in fact, because my line is long. Yeah, that's exactly. If I take a disk, it do a circle around the axis and do a mean on the circle. So I can specify what is the diameter of the circle. I'm not sure what size we are. So now we have, well, 3000 micron. Let's say that I put 100 micron or 500 micron radius. So it will smooth out the data. It's a 350 point with a circle like that with mean around it. And you can have a rectangle, which is in fact not a square, which is not so appropriate. In fact, I prefer the disk. Okay, so this is good. Okay. We can do the same thing, type of analysis, but with a probe. A probe is you click on space somewhere and you want to know the value of the tone of gray. It could be also with the region of interest. What is the value of the region of interest? What is the label of a multi-label value region of interest? So I can do a point, okay? And you see here the position in real space, the voxel coordinate, okay, the value of each of the 2 data sets and their corresponding, of course, position in the voxel coordinate, because they don't have the same density, they don't have the same position and all that. So when I click, I have one world position. Of course, it's 1 point in space, but we say in that data set, it means that it's this voxel, and the other one, it's this voxel. Of course, we can do a disk to do some averaging for the value, and we extract the mean, the max, the standard deviation, and all that. Okay, and for each, okay, and you can undock all of those plugins also. So, and I can control the diameter, but I can control the diameter also with my wheel mouse press and control, like when I will show you about drawing. So I can change the diameter, and this is a circle. Can do it with a square, okay, which is, well, you can do it with a sphere. So now when I click, I do the integration, the analysis on a sphere instead of a circle. and the same time, the same thing for a cube. Okay. So probe tube is very practical to understand what is the relation from space to voxel space and click, oh, this point, I want to know if I'm an advanced user, I want to play with the NumPy array of the data set. I want to know where is that point in space in my data set where the coordinates are just there. And the last click you do with the probe is the last one that is shown here. So you have a trace. So you're not, to take the note of that, you don't need to continue pressing. Of course, that kind of, you can copy paste. Yeah.
Can you make that probe appear in 3D? Sometimes we're trying to find something within the 3D data set. You can find it in the 2D.
I'm not sure. Maybe it's working. I'm not sure. Let's go to a place where I could see it. Oh, well, you can do it in 3D. Okay, you can pick in 3D. No need to take in 2D. I'm not sure if oh, there's a click something, I don't remember which one, that fit the 2D with the 3D. I'll find it. Don't remember. Sorry. Anyway, so, well, here, okay, you see my probe in 3D, and you will see it into the, to redock a plugin, you double click on it, okay? So it docks itself. Sometimes it's a bit difficult. Also, all those plugins can be docked in any of the, on top, on the left, on the right. Okay, so it's a good question. I will try to find the answer and give it later a bit, okay, after the break. But we have time to go to some, let's say, the control of the views, okay? I will put my sample back at the right position, so I will change the orientation that I've a bit screwed, in fact, on my head, go back to the matrix and put it at the right place. I will close the box, I will destroy the ruler, and let's start from fresh. Also, I will reset the view so that if they are orthogonal and all that, and put the full body in view like that. So I have the full data set here, okay, in my view. And now I can go to the panel that is named Scene View Properties. This panel controls a lot, okay? So it depends on the selection you have on screen. Here, I'm selecting the, my selection is a 2D view, okay? So I have the 2D setting. One thing that you can do when you're in the 2D view, and I will switch to gray, tone of gray for this one to make it simpler, because you can change the way you present the data, okay? Now I'm in a slice view. It's the non-integrated cutting. It's a virtual plane of cut in 3D that I'm cutting. The red view is cutting the data set somewhere in space. I can show you where. I will show you later a way to see the cut plane in 3D, the one that is in 2D. But what I want to say is that we interpolate and we do no integration, no min or max or stuff like that. Now, why I'm talking about that? Because I will talk about MIP and MIP. So there's a minimum intensity projection and maximum intensity projection, okay? Minimum and maximum. The minimum is the little m, the maximum is the big M. It's a convention of medical. And also there's the average, okay? So let's say that I switch this view in the MIP mode, okay? Now in the other view, the green line has a dotted line around it. This is the slab thickness that I'm doing the MIP mode on, okay? So I can increase it, and now I'm seeing much more of the, I'm seeing more of the beetle, and for each integration rate that I'm looking at, it's like if I'm taking the slab, looking in, for each voxel, I do an integration, well, not an integration, in that case, I take only the maximum. I can't, this is interesting to find, in medical, they use it to find a small tumor in a big data set. So they slide like that and poof, they find the bright spot. You can do that. Let's say that you're working on lung, or usually you want the reverse. You want the minimum intensity projection. In that case, it's not very appropriate. Notice that I'm doing it on both data sets at the same time that don't even have the same position in space and all the mumbo jumbo. So I'm calling the display is calling the data set and passing a slab and asking for the maximum intensity projection in that direction. If I switch to minimum intensity projection, well, it's the reverse. I keep only the minimum. Those modes are quite fast. Minimum and maximum, they're not super slow. I mean, it's a laptop, okay? It's not the fastest laptop at all. It's a 3-year-old laptop. This view is in mid, but you know, if I move like that, it's quite fast. If I put it in maximum intensity projection, it's more appropriate. And let's say that here I have 94 micron. I will do a minimum, maximum. Okay, sorry. So now I'm seeing a lot. Well, I'm seeing a lot of the. Okay, I switched multiple view to mid. Sorry, but anyway. So you see here, I increase and I see quite a lot of the beetle. Yeah. Well, it was asked, and in fact, in the next release, I think you will have, when you're in MIP mode, you will have a text presenter here that you can drag and draw, and even maybe double click on it to change the thickness with specific value. Yeah, I think it's a good idea. I was about to say that there's another mode that is useful sometime, not in this case, it's the average instead. Okay, so it's the averaging. This one takes more time, of course, because well, it's more difficult to program at scale speaking. So I can have the average. Yeah. Standard deviation. Oh yeah. Okay. Well, I never was asked that, but slab standard deviation. Yeah. Okay. Well, I'm doing all the computation. It's not a big deal to do the standard deviation. Well, it will not speed up the stuff, but it's possible. Yeah. Good point. Thank you. And you see, well, the average, it's not very useful. It's just blurring stuff. But sometimes you have too high resolution for what you're looking at, and you want to have like an average, something smoother to discern. Sometimes slab mode is good. Of course, again, and like every other mode of visualization, I can do oblique with it. Okay. Yeah.
You have a scaling of the relevant for the other. Because when you make a very sick one, you tend to have a very padding in the relevant. You can have
a special.
You say you multiply by 1.5 to something where you have a better contrast.
Well, you know, the average can be, the contrast can be enhanced as usual. Okay. Now I'm contrasting this one, but let's see the other one. I have independent contrast control for each of them.
When you do that, are you changing the contrast
of the thick slab? Well, I'm changing what I'm representing, and I'm working on what has been integrated. Okay, so it's true that it would be fun to have like special control on the multiplication or something like that, a function that you could apply directly on the data prior to integration. I will think about it, but it's a good point. Thank you very much. Okay, now this is not exactly the data set that is needed to show what I will show just, well, okay, let me see about, okay, I will do the 3D, and before the break, I will destroy I will confuse everyone with special rendering. So, and you will see it's kind of amusing. So here, okay, you can change the background, all the detail that you need to do to make a figure. You could change the background, the black background, to something else, something more funky like that, if you wish. It's a bit tough on the eye, but anyway, so you choose the background that you prefer. The same thing here in 3D. Now I'm only looking at 2D setting. If I click on the 3D setting, I will have more stuff to show. Also, yes, you can hide the scale bar, show the legend, the text annotation, and all. If I click on the 3D, now I have access to multiple other rendering pattern. So I have the full 3D, but you can do MIP in 3D also. That's useful sometimes. So now, whoops, MIP in 2D. Oh no, okay, sorry. This is switching the view. It's the render mode. I can have ISO or MIP. Okay, so MIP, it's the real MIP on the selected data set, I suppose. Okay, maybe there's something bizarre here. I will hide this one. Yeah. Well, now I have MIP. It seems that doesn't work well when I have color and multiple objects. I can here enhance the contrast to have a better MIP. And now I'm looking at the brightest part of the data set in 3D. Okay. So now I can enhance to a certain point and I can play in 3D and see all the internal structure. Sometimes it's cool to find something on screen in your object. And I will show you later how to synchronize the 2D view with the 3D view when you click. This helps you to recover where you are and all that. You can play with the rendering quality and what's happening with the rendering. Yeah. Oh, I'm still in orthographic projection. That may be the reason it was not working with this one. No. Okay. It's not the reason. Well, okay. So now perspective projection, 3D map. ISO value is another function where you specify the ISO value. I'm not sure where it is. I must say that I'm not the expert in 3D. So somewhere there's a slider to change the opacity. Oh, maybe it's this one. No, okay. Sorry, ISO value. It's a bit tough for me. I don't know well how to use it. Now I can go back to a proper leveling. Okay, reset the leveling of that object and go back to balance maybe and play with that and see the might again. Okay, you can put lighting. Okay, you can use the lighting and add lighting. So if I'm looking at that beetle might, and I can put different type of shadow and change the strength or how much the shadow is shown, and I can change the position of the light, of course. So this is eye candy to do good picture that you put in the paper or something like that. Okay. I can change the shadow opacity also to make the shadow more opaque or less opaque so that we see it less. Another thing that is for eye candy that in fact, I never use, I don't like it much, is you can play with the focal distance and have some blurring. It's, well, with an autofocus, let's say. So, and the strength, and you can have something that put blur. It's more photorealistic, but in fact, it's people like it because it reproduces photography, but it doesn't reproduce what our eyes do, in fact, because we don't do that. We focus everywhere all the time. So I don't see much of the usefulness, but some people like it a lot. Yeah. Only one for now. Only one, and it's a good thing that you mentioned because I was saying to my developer in the rendering section that we should have more lighting capability, like changing the color of the light. Of course, you can play with the specular, the solidity, the diffuse, and there's tons of metric, you know, to the shininess of an object and all that, and you can enhance the quality, do 3D interpolation also in 3D so that it's better. So look, now it's more, you see more the detail on the surface, but it would be handy to have more than one light, it's true, and be able to change the color of the light. There's yeah, there's ton of setting, and it's an art to make a pretty picture, and well, it's a complex subject because in fact people have all people have their own taste, and we have to put a lot of functionality to the people. Well, okay. Another thing, scene view property is the scene and view properties. One thing that you can do, okay, sometimes you don't like to be in micron, and you may want to be in miles or inch or Armstrong or something like that. We sell, it's very unusual for scientists to use inch, but let's say that it's some American would do it. But you can change the unit and also the angle unit for the view. Okay, so here you see this is the if I switch to orthographic view, okay, again, okay, if I switch to orthographic view, this is the size of the window. Okay, in real space coordinate, because in orthographic there's no perspective, and you look at a solid cylinder like that, a rectangular base cylinder. If I change the unit to inch, you will see that it's supposed to be, oh well, yeah, it's supposed to be written in inch now. Okay, so you can change what's appearing on screen to fit what you want to show in your presentation. Yeah.
But I mean, can you also switch it back to pixels without kind of bypassing the calibration? In many cases, I run into this kind of issue, and I need to have the pixel.
Well, what you would do is to set the spacing to 1 meter, let's say, or something like that, because for the presentation, we're always in real space coordinate, and pixel has no real meaning in that space, you know. So you would fake it, fixing your voxel size at 1 meter. Also, something I didn't say, and it is kind of unusual, is that we can have fully anisotropic data set in the voxel space. So X, Y, Z spacing can be all different. Okay, voxel can be any type of rectangular shape object. So it's unusual to have X, Y difference. Okay, there's not a lot of acquisition protocol that give you that. But when you do a derived series, since we optimize the sampling and all that, you will have different type of, if you're in an oblique, you will have different type of spacing in each direction. Most of the time, you guys in CT and all that, what happens is that you have maybe a thicker Z than the XY, and you have an isotropic XY plane. But just to say that some complexity of our software and the coding of the code back in the back come from that. You know, NumPy and all that, you cannot do slicing in any direction using non-isotropic voxel. So we have tons of code to manage that. It's necessary because, again, we come from medical and we're used to deal with strange acquisition space where the voxel can be mostly anything. With an MR, you can do very, very strange things. Okay, and here it's the bigger screenshot button. Okay, export screenshot, export the screenshot of what you see on screen at the resolution that you will specify. Here, a 3D view, I think the maximum is 4,000 or 5,000. I'm not sure, but you can do 4,000 something. You can make it transparent or not. Let's say that you want a floating beetle or floating mite on something else on your paper. It will generate an alpha channel. So it will be a RGBA image instead of RGB image. And if it's a 2D screen, okay, this one, for instance, I think I can, even if I'm in voxel interpolation, I could export it as at a much higher resolution. Something like that, I think would go. So it will ask me to save it as a PNG, but well, I could do it. So it should work. So like this, and I can save it in multiple formats. Of course, we support JPEG, bitmap, TIFF for the exportation of data like that, because we won't, well, that's about what people need. Yeah. Visual, well, a slice like that, the present with the annotation and all that.
No, I mean, to be able to have an contrast level when you take this picture to make something else. So for instance, because you spend a lot of time to make exactly the orientation you like and so on, you want to have just slice.
Yeah.
The full
yeah.
Yeah,
it's a bit convoluted, but yes, it's possible. You position your spot at you choose your oblique, and after that you derive a series. After that you select the slice. You generate a new image 16-bit, and when you go to export, it will ask you if you want to apply the level, the brightness contrast. So you will have that slice on that oblique on that. But it's true that it should be one click instead of multiple clicks. Maybe I've done it already. You know, I have the bad tendency. I start coding. I'm with our Git or something like that. I push the code, and the Git say this file already exists. I look in the file. It's something that it's exactly the same code, line to line. I'm very consistent. Name's not the same name of variable. I've done it 5 years ago. So it's very depressing to have a so bad memory. But I will check later if tonight if we have already done that. I would not be surprised. Okay, I think it's a good time if you're to take a 10-minute break. And after that, I will show cylinder and spherical unwrapping to show what's on the surface of a cylinder, which is practical. Yeah.
Anton,
So we take 10 minutes break and we'll be back.
yes, can you please
Shortly.
tell Nicolas
Thanks.
that, can you please tell Nicolas that we only see half of his face all the time? And also to repeat the questions because we don't hear the question from the live audience.
You see only half of the space. What do you mean by that?
Half of your face.
My face. Okay, my
Well, we
face.
don't see your mouth, we don't
All
see
right,
when you
all right.
speak, and then you move your
Yeah,
hands, we
I
don't
was
see.
concerned. My face, I don't care too much. Merci, Josia. I was okay. Earlier, I was trying to find a slider to do isosurface. Someone in the room teach me where to find it in my software. That's cool. Thank you very much. And well, you know, sometimes sliders change place, and I didn't knew where it was. So you can change the value of the ISO value. The ISO value is computed on the GPU. So when you have clean data, not noisy and all that, it works well, but most of the time it doesn't. So it's not super useful, but it can be sometimes. So I will switch back to normal rendering, default rendering. Here I have, I will go quite fast on certain stuff because I want to cover segmentation. So I will just show that we can do a virtual floor, but something more important, you can have multiple scenes. So you see that here with in the layout panel, you control the views, what kind of views you show, 2D, side by side, 3 by side, horizontal, vertical, with 3D or no 3D. Like this one is very popular among certain people. So this is cool. But you can have multiple scenes. Multiple scene means an object can be visible in one space and not visible in the other space. Sometimes it's useful to work when you have a big machine and you want to work on multiple samples at the same time. It can be useful. It's not so, yeah, useful. Use all the time. Well, okay. So something that I wanted to show, and this data set is not appropriate. I will try to do it very fast because we have to cover the segmentation tool, and I noticed that we're a bit late. And if after the basic segmentation tool, I mean the manual and semi-automatic one, if we have time, I will cover more about the derive theory, how to derive multiple data set with cropping, but also not only cropping, changing the density of voxel, reducing and stuff like that. That is often useful. I will load another data set. Let me check. It's here. And I will take the fiber. Oh, sorry, the fiber. Okay, so I load a data set, which is very simple data set of a kind of, in fact, I'm not sure what it is, but it's a microcity coming from Zeiss again. So we have so much data set from Zeiss because we are distributed by them. So here I have little cylinder. Sometimes it's interesting, and it will, in that case, not, but it's just to show you that it's sometimes interesting to look at the data in the perspective of the object that you're investigating. So there's a panel to generate shapes, okay? And in particular, sphere and cube, sphere and cylinder are have special behavior. Okay, so if I click on the middle, I will push that aside. If I click on the middle of the cylinder, I can move it around. And here I can, of course, change its radius. Okay, and you have, when the cylinder is here, you can also change, align it and change the perimeter. You have data and all that. But what I wanted to say is, you see here, the cylinder is quite, well, somewhat aligned with the data. I can ask for a view, let's say this one, to be a cylinder unwrap of that cylinder, a cylinder unwrap view. So I select the cylinder, I go to view and non-planar 2D view. So now I'm in the cylinder space. So I can change an offset of theta, okay? So I'm looking at the data on the surface of the cylinder now. Okay, so if I move the cylinder, okay, I can, well, sorry about this one, annoying. I can move it around and I'm looking at what's happening at the surface of the cylinder. We see it more here. And what I'm using is that I can synchronize. So if I click in the cylinder view, my 3 other views are put in the middle of that, of the point where I click. So this feature, strange feature here, is somewhere like in that. Okay, there's it's here, you see? Whoop. It's that stuff here. So it's at the surface of the cylinder. Okay, so I can change the radius of the cylinder in that space. I can change an angular offset to change, like unwrapping different portion with a different offset. And of course, it works dynamically. So if I tilt the view, I will see stuff like that. Okay. Another cool stuff, another cool way to use that is with sphere. I can put a sphere on screen somewhere. So I will hide this one. Okay, now I have a sphere. I can switch this view to a sphere unwrap. And I only have implemented 2 types of sphere unwrap. Let me switch back to this. So I have a sinusoidal projection or the equirectangular projection, okay, of the sphere. And now I can control phi and theta, of course. Okay. Not always practical, but let's say that you have a spherical object and you want to understand what's happening at the surface, you can do that. And now I can export that view, that data set, that slice that I'm looking at as a proper data set. So you could unwrap a can, let's say a Campbell soup can, and see the Campbell sign. Yeah, so you would have your tomato soup unwrapped like if you had cut the paper on it. On a sphere, it's a bit different, but let's say you would see the map mode expressed like that. This is equirectangular, and this one I had a lot of fun coding that. It's a sinusoidal projection that people don't use usually in cartography, but again, you can do synchronization. And more than that, you can draw on that space when you're doing region of interest. You can use that like that referential to draw in the other space. I know it's a bit arcane and not often useful, but we did that for people dealing with the cylindrical core, cylinder core, and they wanted to have a very flattened view of the surface and understand where they are and have the synchronization at the same time. Sorry, I didn't implement the MIP view of that. I could have done it, but it's when you think about it, it's a bit strange. We have 2 other type of non-planar projection. One is a Bézier surface, and the other one is a RBF surface. This is useful for unwrapping circuit and stuff like that. So people scan often the electronic circuit, and they tend to be not totally planar. And you want to have all the via and all at the same place, so you can move point and have that space. And it's a bit hard to manage, so I won't show that because it would take a bit time. But remember that it's possible. Yeah. Yeah. It's an interesting question. In fact, this view is positioned at 0, 0, and it's on the XY plane at 0, 0. So I fake where it is, and I don't show it at the intersection in the other view. So if you were to put another data set at that point, it would work. Yeah, it's true that I also, if I copy my data set, okay, so I have another one, but in fact, I make the first one less opaque.
Sorry, Nicolas, can you repeat the question, please?
Oh, yeah. Okay, the question was, can we overlay the value on that, another data set on this? It's a bit tricky to do. But in fact, this kind of unwrapping is like the other view. You can have as many fusion data on it. So if you have 3 data sets at the same spot and you extract the cylinder, you will see the cylindrical projection of the 3. But it's not exactly what you want.
So you said this could be made for code.
Yeah.
So when you do code, the part of the extremes,
Yeah.
maybe to
Yeah. Yeah, no, it's not done yet, but it's a good point. To do a proper core analysis, in fact, it's true that I could put like temperature, radiation, whatever they measure, because they measure a ton of stuff, and you should be able to see a graph on the side that is related to that and to rotate it when you're in. No, it's not already done. But in fact, it was asked by Los Alamos, not for exactly for coring, it was for analysis of some nuclear foam cylindrical of missile or something like that. In fact, I should not have that. But yeah, no, I'm not sure. It's not true. It's something of that sort, but I don't know exactly what. So the sphere, the cylinder, and you can have here, my 2 data sets are at the same spot and they have the same opacity. If I change the opacity of the second one and I make it transparent a bit, and also that I change its position, well, you'll see that I'm able to do fusion in that space. So translate, rotate. I change the position of the copy of my data set, copy data set, translate, rotate, click on the button so I can move it. And you see that I have 2 data sets, one on top of the other with obscuracy and all that. Yeah.
For the unwrapping thing, do you have also a possibility with a curved line that you define yourself? For instance, if you have a roll of paper that you can roll like that, you would like to make a spiral stick and roll completely.
This is a good question. In fact, it's a bit like
just repeat the question, please.
Okay, yeah. So it's the unwrapping. The question is unwrapping of Dead Sea Scroll or stuff like that. Mummy people like that kind of stuff because the people in the old days tend to roll out what they were writing, and you cannot unwrap them, of course, because it will go to dust. So in fact, a bit yes and no. Now we don't have the total unwrapping that you would like, but we have something a bit similar, and I will show you how. It's the and it's not on view. In fact, well, it's not a view like that. I'm supposed to work on exactly what you're asking for, but for now, what people could do is take an annotation and, like I did earlier, trace the contour of your whatever and ask for a channel unwrap of that on an oblique, on the normal, on the perpendicular of the path. Okay. So now if I do export a data set like this, okay, or generate a mesh, this one, and I take the fiber copy, yeah, and I say, oh, well, a number of pixels, 200 pixels. Okay. Now I will have a data set that is not correlated in space. Okay. But it's a kind of what you ask for, but not exactly. So if I go and ask it to be like this and put it in 3D, it's a cylindrical data. It's a data set that is a square cylinder, but it's the unwrap around the path. Okay, so it's kind of not exactly what you need. In fact, what you need is you draw the path, and after that you would have an handle to turn the plane and do it. Another way, well, yeah, but sometimes it would be even better if you had 2 paths to define the plane in between and multiple paths to have like an unwrap but it's kind of intense. I hope I will have time to.
Maybe it's not value surface that can be.
Well, this is like another way of generating the point to generate the path. The question was, or the comment was, why not use the tone of grid to generate the plane, in fact? But often it's not easy because, in fact, what you may want to have is generate the plane based on the segmentation, because the tone of grid on the plane can be not thresholdable, not the same threshold on all the plane. So in fact, I would like to do the same thing, but on a surface that's generated via a segmentation. And even more, what I want I want to do the roadkill stuff, they call. Roadkill is to take a mesh and flattening it, okay? And have the data of the mesh on top, on the flattened. But when it's a manifold and it's a kind of tricky problem, in fact. Yeah.
Maybe I'm misunderstanding, but can you choose that path in 3D, like going through your slices? Or do you need to like rotate to the oblique way you have all in?
No, I didn't talk about something interesting and that I forgot and someone mentioned to me, because I'm the one who coded that part, but I had forget that I was able to do that, is that when you're in the MIP mode, when you click and you put point, it will go to the maximum intensity, okay? But you don't have, we used to have the best way to edit a path, a complex path, is to work in a curved planar reformat, where you have like a Venetian stored around your path and you move it in that space. This is the way people in medical do for doing centerline and vessel and branching and all that. We used to have that, but in industrial, there's like 1 out of 1,000 that wants to do that, but we already have the code, so sometime I will be forced, in fact, to do it, I suppose. So stay tuned. Maybe next December or the release after it may be required for me to do curve planar reformat, which is not so. It's a lot of code. It's not so easy.
Nicolas, could you maybe demonstrate, because there was a question from online about cropping using the shape tools?
Oh yeah. So something that people need to do often is to crop, okay? So I will remove everything and keep only my simple data set. There's not much to be understood on that, but anyway. So we saw that we can derive a series of any angle. But another way of thinking about it is, okay, you can also take the clip box, clip it, and extract the data that you have clipped. This is data align, okay? This is simple. But you can also use a shape like a cube, okay? Whoop. Sorry, down there. A shape like a cube that you put on in space and move it around in any oblique that you wish. Sorry, those anchors are small. Okay, sorry. And position your box like that and extract that data set if you wish, okay? So now you can say extract structure grid from that box. So it will generate a new data set from the box, okay? And in that case, it optimizes the spacing so that it has the right frequency. But the box itself, you can edit its frequency. So you could fix yourself the spacing in the box and ask to derive it. So now I have a new data set that is exactly at the same position as the other. So if it's this one, okay? And that was positioned like that. So you can position yourself in any oblique, any position, and put the box and derive a series. Yes. For ROI? Yes. In fact, okay, can you derive a series with a ROI? What you would do is take the ROI, ask for the Ferret box so that it's aligned depending on what you want, okay? Let's say that you're segmenting a fish that is a cylinder that is not well oriented. You can segment it and afterward ask for the minimum box around it, the Ferret box, we call it, okay? And ask for extracting the data from that Ferret box. I made almost everything needed to do jigsaw in 3D with, you know, archaeologists, sometimes they have the tooth of the dinosaur on the soil and they have the like nest bed, okay? It's one big stuff and the thing is completely disassembled. But I have almost everything to reassemble the shape. It's a bit long, but you can reassemble the dinosaur in the virtual space in volumetric space. It's kind of possible. So, but it's a bit over your question. But region of interest. Yeah. Yeah, it's here when I'm doing extract structure grid. This is typical name from a programmer. I'm the one who did it. It's not good. Structure grid. There's 3 types of structure grid: ROI, multi-ROI, and dataset. So they are all equivalent in the sense that they are living in a structure space. So you can apply that cropping pattern to all the 3. But of course, we may have chosen a better one. But yeah. Okay, and the box itself has multiple functions that I cannot show it. There's too much stuff, but you can make it wrap on object and de-align on object, or take the minimum or stuff like that. That enables you to add let's say that you have multiple objects on screen and you want to have the enclosing box of all that. It's easy to make the box that enclose, and after that derive a new series out of it, let's say, or derive a new ROI from the existing ROI, and it will be resampled on the new axis also. So that's a good point to go maybe to, well, okay, there's tons of other tools that I could have shown in that panel, like how to do multiple screenshots. You just drag and drop here and you have a screenshot, and you can do a stack of screenshots. 2D movies, it's crazy, but sometimes you need that kind of stuff. Okay, you look at and you want to specify in time or in space, and you want to go across all the slides, and you want to save that as an AVI to present to someone with everything on screen. This is possible with that. There's other different shape, like the rectangle that can be skewed or warped to make a shape, a surface, like I said, Bezier surface or RBF surface. So there's a lot of tools there, but I think we should go directly to segmentation, which will be required tomorrow when I talk about more advanced tool of segmentation, which we should start with the basic of what is a region of interest and how we do it and how we paint it. So here it is. So this is in the segment tab, you generate region of interest. There's 2 types of region of interest. One is monocolor, if you wish, and the other one is multicolor. Why would you have both? Oh, it's a good question. We started with the first one, and now someone could say we should just use multi-ROI. The advantage of a multi-ROI is that they're auto-exclusive. So one pixel can only be of one color. So it's the appropriate tool to train a neural network for 4 color, because if you have 4 different ROI that are all living in space and that are overlapping, what do I do with the confusion of the class, you know? And yeah, so but ROI are still interesting to be used sometimes. They are lightweight. Our region of interest representation in code is a black-red tree, so it's interval. It's not a dense matrix. So an empty region of interest weight approximately 0. A full, like all the voxel tag weight approximately 0. In fact, 2 indexes. And the more complex is the data, the segmentation, the more it weighs. But the goal usually the goal of segmentation is to simplify. I hope that what you have to segment is not 1,000,000 objects on screen, and it's something that has a shape or something like that. It's true that sometimes you deal with, let's say, grains of sand and stuff like that, but you may have 1 million out of them. It's anyway. So the representation would be not so efficient at that point. Our region, our multi-ROI, which is different object on screen, can handle up to 4 billion different objects, 4 billion color. I never heard of people saying it's not enough. And I think it's most of the time well enough. And anyway, what do you do with 4 billion statistic of object? It kind of beginning to be tough, but it's everything should work up to 4 billion for the number of color. Of course, you won't attribute manually 4 billion color. You have color ramp and all that stuff. So let's start with the very basic ROI. Okay, I'm generating a region of interest. It has a shape. Okay, I'm creating a new structure grid, but it's based on the shape of the fiber. Okay, so, but it's freestanding. It's just I want to provide a shape. You could have another object here, another multi-roy, another data set that has not the same orientation and same density, and I could choose him to be my my size and frequency of voxel. So it's not the region of interest are data set as much as data set as the tone of gray image. That's what I want to say. So you can move them out of sync and all that. It's not bound to a data set. Some software have the concept of a region of interest is bound to a data set. In our software, it's totally disconnected. It's another data representation that is not tone of gray. For the binary one, it's 1 or 0 if you wish. For the multi-roy, which is up to 4 billion color, it's 1 to 4 billion, 200 million, something. Okay. So I generate a new region of interest. It's green. Each time you create a new one, it has a new color. It's kind of ending. So, okay. I need to talk about very, very simple tool that you often or sometimes use that is practical. So here I can define a range, okay? And the range, I can show it on an histogram. And this is the selection range. So if I take the upper Otsu, let's say, okay, of that histogram, it happened that it chopped it between the black and the real data, annoying. But I can move it like that and say, okay, this is my fiber. I know it's a super simple data set, but you have to start to show a lot of tool. I need to have something simple that it goes fast. So now, okay, I have selected in red in 3D by a range that I can specify manually, okay? And I can change also what is plotted because I can zoom in the histogram and all that. And I can add to that region of interest what is in red. Boom, now I have selected everything. I will clear, I can invert and clear, okay. But okay, now the range tool is working for almost all the other tools. Let's say that I'm using the pen and I put a seed, okay, in one of the red spots. Now, okay, you know, all of you know about morphological operation like dilate, erode, open, close, smoothing. Smoothing is a bit more unusual. It's not really totally a convolutional operation. It's just you go and you do a Gaussian diffusion and you cut the Gaussian just to smooth the voxel at the surface. But my point is the dilate now only work, okay, on the, as you see on screen, and I would put more. Sorry about that. I will put something more bright like this so that we see correctly. So I'm dilating in 3D with a cube, okay, on the full data set with a kernel of 3, but it cannot go outside of the range, okay? So the range bound my operation. This is often useful when you're able to segment something, you are able to get the threshold and you want to grow it, but not over that, okay? Of course, you can even specify a range of action from the 12th slice to the 200 00 slice, for example. So it will not, let's say, or 70. You can constrain the action on specific range of slice, and here you can even skip slice. There's well, here you see the syntax. Whoops. So you can out of 1 of the 3, stuff like that. So it's a slicing operation on the dilation and all the operator that you have here. And as I said, it's only working on the range if I have specified it. If I say no range, well, it will go, well, and I will remove that. It will go outside now. It's not bound to the range anymore, okay? Something that is useful often, okay? And here I'm using the tool to draw, okay? I draw, and I will explain it later a bit. I draw a sphere. Often I have holes in my region of interest. They may be 2D, 3D, or in 2D. Often I need to be able to fill the hole. So this enables you to, I blew the sphere somewhere. Which one? Okay, should work. Maybe it's the range. Yeah. So now I have fill it. It should have worked in 3D. I don't understand why. Anyway, so I can. This is useful when you want to fill a hole in one direction or in another direction. So it goes and fill the hole in each axis that you specify. Of course, you can clip the region, remove what clip the region means. Let's say that I have opened my clip box, B for clip box, and I now constrain, okay? I can say, well, add this or remove that very fast. So you have the cube, you select, okay, I want to add this or remove that, etc. Interpolate is a bit tricky, and it's like on the two Z's, on certain axes only you can use. You put two, I will do it, you will see, you'll understand. I will clear the region of interest. And now you need two overlapping region of interest, let's say in the center like that. And oh, not a sphere, sorry. I will draw a circle only. Add, let's say 200, and go and draw something smaller here and interpolate in the z-axis. It's a bit long, it's a convex operation. And now I have a kind of cylinder, a cone from the big circle to the small circle. These are not often useful, but it's important to know about that. Okay, I can override the data with the region of interest. So I can say my region of interest, the data I want it to be 0. Now it's a hole in the data set. This is fun to sculpt, in fact, to remove, invert the ROI, throw everything away, and you only have what you have segmented. You can also, now there's nothing there, so I cannot do split atotsu, but let's say that I put something underneath. Okay, I do a sphere here, I draw a sphere, and I can say split atotsu. Now I have two ROI, one which is the background and the other one the foreground. So it has done the Otsu thresholding, which is the find the split in the histogram that minimize the intravariance and maximize the intervariance. Yeah, I coded, I don't remember exactly. Sorry. Okay, so, and of course you can do with the region of interest, you can split, you can export, you can crop, you can override, and you can generate meshes. And this is important. Let's say that I go back and I segment one of the fiber. Okay, I do a split atotsu again, and I take only the fiber stuff. Okay, so I have a couple of fiber. I can export the fiber itself. I select it, can export this fiber and two different types of mesh. A marching cube, which is a mesh with triangular face that are sometime at 45 degrees, and or a cubic mesh which follow exactly the voxel limit. This type of mesh are useful for people doing FEM, because when you have the surface, you don't want to lose the corner on top of the surface and have a hole in between. By the way, in the next release, we'll have a mesh, a 3D mesher, tetrahedral mesher included. In fact, we have included NetGen in the software, so you take a multi-ROI with 4 billion color, if you wish, and it will export it as a 3D mesh that you will be able to see on screen, control a bit the density. I needed to show it on screen because there's some free parameter. You can generate the mesh and export it as CGMS and a couple of classical format for ANSYS, Abacus, and those type of software. So next release, 3D mesh support. So here I can generate a mesh, a simple mesh, out of the segmentation. So now I have, in 2D, I see my mesh, okay? It's a bit rough because the resolution is not so good. And here, if I show it in 3D, of course, I see the mesh also at that spot. So it was a spherical region of interest from which I have extracted the Otsu threshold, selected each of those guys, and extracted the mesh out of it. Okay. Another mesh that is useful to sometime is to, well, meshes. Now I can introduce meshes. So I have region of interest, simple region of interest. Now I have meshes. Meshes are a sparse representation. It's a surface representation. Those surface representation can have scalar values on it at the level of the vertices and at the level of the faces. So you can put as many scalar value you wish on the mesh. Particularly in that case, you can extract a thickness mesh, okay? So the thickness mesh, I won't even do smoothing. Now, if I look at the thickness mesh, it's a mesh with color-coded, the biggest ball that you can put underneath each vertices, okay? So here you see the mesh, and you see all the characteristics of the mesh. So how many triangle it has. It goes very, very fast, very big, okay? So there's 350,000 vertices and a triangle for 178,000 vertices. We can compute the ferrite diameter, which is the smallest box for the mesh and all that. But what is interesting is that, well, you can look at the mesh in multiple ways, okay? You can ask it to be shown like that with the scalar value. You can outline it to see the detail of the triangulation of the mesh also. And you can say, I just want to see it in wireframe, okay? This mesh, and you can control diffuse and all that. The lighting on the mesh is much easier to do than the lighting on a volumetric representation. So you have much more control, and also it's shinier and it's much better well behaved when you play with rendering. But here I can extract the distribution of the vertex scalar value that I put. This is the distribution of the biggest ball that I can put under the mesh without busting in. Okay. Also, well, as a scalar, as a unstructured grid, and also with the multiroid, I can map scalar value from something else, from a dense representation, meaning I want to put value of tone of gray, in that example, on the surface of the mesh. So each vertices will pick the value of the data set and put the tone of gray as a scalar value in it. So the scalar value system is that for each vertices or each face or even each edge, but it's not shown here because we don't need it, you can put as many scalar value as you wish. And you can use that later on to classify part of the mesh, if you wish. Also, you can say, I just want to see the big part, the small part, and stuff like that. But I will, just because it's fun, I will do a mapping of the fiber on the mesh. So now I have a new scalar value on the mesh. Whoops. That is the density of fiber. So this is, well, it's the color ramp. But if I choose the gray value, well, this is the value of the gray tone of gray that was underneath the mesh I just done. It's the value that is in the fiber data set underneath. Okay, so I have mapped a dense field on a sparse field. Yeah, of course. Wow, this is another problem. This is disambiguation of objects that are touching, and it's something I'm supposed to do soon. In fact, it's because what time is it now? Yeah.
So the question for the online is just about touching fibers. What happens?
Yeah. Sorry. Well, it's now the time to introduce watershed. Watershed is a classical algorithm to disambiguify objects that are touching. Okay, and it's not perfect. Sometimes it's difficult when you have very different size of object and their convexity or concavity is very pronounced, and peanut shape object and all that is difficult. But for such a well-behaved data set, it's not so tough, and I will show you how to do it. So let's go back, and I'm not, the problem here is not I will reload it to remove the, well, okay, I know I can live with the old, it's okay. We'll just destroy those region of interest and meshes and stuff like that. And we will segment the fiber, but a lot of them are touching, okay? So I will segment them by range. and add this to a new one. And we'll make so that they touch. Okay, here they're touching, some of them are touching, some of them not. Okay. So what is a watershed? Watershed is an algorithm that grows from a seed, an object, until it hit a frontier. And if those two seeds grow together, they will hit a watershed line. And this will be the separation of the touching object. Okay, so I add that to a new region of interest. Now I have a new region of interest. So the classical way to do a watershed is to invert your selection, okay? So we'll invert the ROI. Now we have the ROI segmented in 3D, and it's an easy data set. To demonstrate watershed, it's a good one because I don't have to spend tons of time doing the segmentation. Because usually the biggest problem is segmentation, and after that, it's a quite interesting problem to try to separate the object. So I inverted, and now I will do a 3D mapping of the distance map of the inverse of the region of interest. So what does that do? It generates an Euclidean distance map from the exterior, meaning from the pink color now, to the interior. So I will end up with a mountain, if you wish, okay, like that. And I will invert that. Well, I'll show you. So now it's computing. The distance map is computed in multi-thread. It's quite fast. This is a laptop, it's not so fast, but yeah, well, it's a good implementation of a distance map. So if we look at the distance map itself, we see that it's like the distance, each point, if I probe, okay, if I probe, I can see that in the distance map, it's the distance to the exterior. The value is in micron, and it's the distance to the closest point on the frontier, in fact, okay? So it's an Euclidean distance map, we call that. This distance map can now be thresholded. Okay, we need to have seeds in each of, the goal is to put color on each of them and grow the color until they touch. So I can define a range in the distance map space, okay, and select something to separate a value that separate the object, but keep some red value so that I have at least one seed, hopefully one seed only. Okay, so this is the trickiest part, and I'm starting to code the adaptive thresholding, adaptive watershed that gets rid of most of the problem that you have doing that kind of stuff. So now what I will do is do a ROI with the selection. Now I will have color in each of those, but they are still not individual color. Okay, so now I have green everywhere, and hopefully only one piece of green in each of the fiber. Okay, I should have done it more carefully to be sure, but let's say that I've done it right. Now the rule, what we need to do, okay, is to separate those green color to attribute them each individual object in green a specific color. Transform the region of interest, simple region of interest, to a multi-region of interest. This is easy. You go here, you right click, and you say connected component. And you choose the connectivity that you wish between 6 and 26. 26, it means that objects that are even touching corners will be considered one object. And in that case, you prefer that this happen because sometimes it's a bit disconnected in the distance map. A way to make a better distance map would have been to smooth my ROI at first so that the distance map is smoother, okay? But it would take time. So I will do a 26 connected multi-ROI. It's done. And now I have each of them have a color now. And I will hide this one and this one, okay? So now I have color for each of the individual fiber, a seeds, we call, for each of the individual fiber. Everybody is following. I'm going a bit fast, but that's it. So now we will, I remember that my distance mass was 0 on the border, maximum on the top. Now we need to invert it. It's like that. We need to do a valet so that it grows instead of sink. So what you do is you take your distance map and you go to modify and transform, and you invert the tone of gray of your distance map. Okay, so when I do that, I create a new data set. It's very rapid because it's not a big computation. And if I look at it, the top is at a value and the bottom is at minimum. So the interior of the fiber is at the minimum. We have seeds in those spots and we will make them grow now. To make so that the color doesn't spill out, I need to have like to mask where I want to go. This is my mask. I think, or the reverse. Oops, I have a blank now. So I think it's the reverse. So I will grow my region of interest in the inverted distance map using the mask, the purple mask that we're seeing now. So that it doesn't need to cover the white. It just needs to cover all the pink and separate those two objects, for instance. And we see that these two objects have specific seeds in them. So I go to the multi-ROY, I right click, I ask for the watershed transform, and I say my landscape is the inverted distance map and my mask is my new ROY. Yeah, exactly. Okay, I will name them properly. Sorry about that. So fiber. And I will do it again. So watershed transform, inverted distance map. This is like, there's a way to do it more automatically, but this is the, let's say the recipe to do a watershed. Now it's doing the watershed, it's growing the seeds in the mask. The only error I could have done is inverted the mask or not. I don't remember if I specified the interior or the exterior, but at the speed it's going, I think I did the right thing. So now the colors should have grown and they are separated, kind of, okay? Of course, I would need to do more proper pre-filtering of the distance map so that there's no multiple minimum and I'm able to do decent seeds. And for that, like I said, the trick is to smooth the ROY, make it more well-behaved. Although this is the classical watershed, it's not working well when you have different size of object because you're not able to define seeds everywhere at the same time. So there's advanced watershed technique that could be done manually here, but that will be included soon in the software. So now I have multi-ROY with multiple color, and if I show that in 3D, my multi-ROY in 3D, well, I have that. So I have my separated object in 3D. Okay. And now I can extract statistic out of this object, like size, volume, orientation, and all that. Yes. Another question. I don't hear it properly. Yeah, you can do that. I don't understand well the question, but the question is when you have objects that are still connected and should not be connected? Is it that? Yeah. Well, they have two colors now. They are touching, but they are two distinct objects. Yeah. Yes. Well, yes, of course. If I do a solid mesh out of it, okay, I would have a common surface between. So and yeah, exactly. Totally. So if I transfer my region of interest and I transfer it as a solid mesh, I will each tetrahedral knows its corresponding the touching other, and the other may have another material. So yes, it will be conveyed through that. But this is simple. I mean, it's just proper computer science. But I mean, the real problem is that sometimes it's very tough to separate the object. But in fact, what you do is multiple separation. So you detect in a way which are not separated. You classify. You use our classification module to separate them, and after that, you do a watershed just on them to be able, or something like that. But we're working on deep learning type of separation of object, but in 3D it's kind of tough. But we're working on that. Also, the training data for that can be tough. But stay tuned. We will have more stuff to show at that level. Okay, I will go back to basic segmentation tool. Okay, and I will use the multiroid that we have here. So I will hide that, and now I have just the tone of gray and the object here. So if I pick this and click there, I think, yeah, it select the object. So you can run into that, okay, and click and select the object. Now they are color coded. Okay, they are color coded by label. It's an arbitrary number that comes from the creation of the object. So on the top of the data set on this slice, you will have label 1, 2, 3, and stuff like that. So it has no real meaning. In fact, it's just an identifier to discern them. But I could have called them, I could have color code them with volume, orientation, surface, and stuff like that. I can have tons of statistics that I can add to those objects. But now I just want to show what kind of operation you can do with a region of interest like that. So, and it's the same for a roid and a multiroid. So earlier we saw that we can, I did draw like this. Now I have this label 683 selected. And this label, if I do look at center of mass, well, I will change it, single opacity of this guy alone. Well, you see, it's this one that changed. Okay? Because sometimes when you have a lot of stuff on screen, it's tough to see. So I can use, I select it, I can draw and add or remove out of it. Okay, so control, remove, draw, everything. Okay, I can do it in single plane, and it can be in any oblique also. I can work in I can work in something like that and draw that label. Okay, I can, this is, well, it's not a good drawing, I'm not segmenting anything. Okay, but I can empty that label if I wish. Okay, clear the label, and now it has 0 count. Okay, and but I can re-add stuff using the range, for instances. Okay, my drawing, you see the red. Okay, now my pen only work on the red, 2D or 3D. Okay, and I'm in an oblique. Okay, and you see that it's mutually exclusive. When I draw on the other one, I'm eating it, if you wish. Okay, better than the range, in fact, is the Otsu brush. Okay, Otsu brush is just a brush that do a local Otsu on the circle that you have selected. So I can have an Otsu brush and select lower or upper, and I can do the Otsu calculation on another data set, not even the one I'm looking on screen. So you have a signal, another signal, you want to threshold with one, but see the other when you're working, it's possible. It's a bit weird, but it's possible, and sometimes cool. So here I have no range, and this data set is easy, I know, but it's just to demonstrate the possibility. Okay. Also, if you have local Otsu, you have adaptive Gaussian, you can do point and click. Point and click when there's no range, okay? And I will switch to the ROI, it will be more easy to understand. And I will clear it, sorry. Okay. I know that for some of you, it's like boring because you've seen all that, but it's kind of necessary to see that before going to deep learning and stuff like that. So I can use the range like I did, okay, and paint only on that. But I can, and also I can do that and do point and click on the selected range, meaning that it will take everything that is connected to that object. Okay, this is in 2D, but I can do it in 3D also. So now, so I selected the red connected in 3D. So I click on an object, it selects what's underneath. Okay, everything is connected now. These are connected somehow in the voxel space. If I have a tighter range, it will disconnect them or something like that. Okay, so you can play like that and remove and add part of the object in 2D and in 3D. Also, this is a bit weird, but you can click on another ROI. So you can remove part of yourself. You have multiple objects and it's not bound to the tone of grid, you can click. Or you have another ROI where you have the grain and one with another type of grain, and you click on the grain of one to add it to another region of interest. So you can back and forth go from one region to the other and select object in multiple regions like that. Okay. Yeah, of course you can do thing. Well, this is the point and click, but only the surface. So it's a bit. Yeah, so it extracts only the surface of what you've clicked. Sometimes it's useful. It's like doing the same with minus the error. Okay. Yeah. When you have multiple regions of interest, you can do binary operation on them. Of course, you can keep the touching object, intersection, union, subtraction, and all that. And for that, it's like if you have multiple regions of interest, a new one here, and I draw freely on. I draw freely on it without thinking about the range. Okay, and I have wow, that's a strange color. Okay, I have that. I can draw here, and oh, full brush, let's say, and I draw over that. Okay, now if I select multiple of region of interest, that panel appear, and you can do union, intersection, A minus B, remove intersected, keep intersected, create a new file, a new new region of interest, or keep it in the same. And you can do combination between multi-ROI and ROI in that. So it's all the binary like operation are there for you to use. Something that Anton likes very much is the grid drawing. And I think, yeah, it's cool. So
smart grid.
Smart grid. Yeah, smart grid. Sorry. Okay. Region. What's the problem? Oh, it's in 2D. I select. Okay. So this is a automatic watershed on grid. Okay. So it's like painting a mandala, but without the trouble. But it's almost as fun. So I will put myself in XY just to show you again. And so the grid is in fact, it's a watershed on a grid. Yeah.
I was wondering, would the point of this tool, is there a way to like hard code and then sometimes pretty big data set, get arranged like on the grid, and then like, oh god, for 3 hours, everything is frozen, it's affecting to like net the entire
well,
set together, didn't quite get it.
yeah, it takes time, but well, how would you limit it? The problem is that on a sphere. No, it's not a bad idea. No, we don't have that. It would be to use a sphere as a mask to be able to do it. There. Yeah, makes sense. Makes sense.
The question is about limiting the.
Yeah. Okay. Sorry. The question was about limiting a point and click in 3D to a certain area. And well, it's tough. You would define something, but often, well, in simple case, it's line, but sometimes it's very convoluted and it's hard to where to put limit and all that. But it's a good mention. And in fact, it would not be very tough algorithmically speaking. I will take that in note, and it may be a good addition for the software. Thank you very much.
There's a question about, can you export each class in a multi-ROI in different meshes?
Yeah, different meshes. Well, you can have a mesh that has the scalar value of all the labels, okay? But like I said, multi-ROI can have up to 4 billion, and you don't want to have 4 billion the same object. But it's possible to extract all the classes of multi-ROI as multiple ROI, and you can multi-select them and generate a mesh of it. It's all possible. It's quite easy. I can show you. So I select the multi-ROI.
There's something wrong with your microphone, Nicolas.
Like what?
Okay, now we hear you. We couldn't hear you very well. Okay.
So I can select that and extract each class as a ROI. Now I have a ton of new objects, and I can select them and export a mesh and it will be multiple mesh, as you see here. It's all distinct objects. But usually you don't want to do that because it becomes messy very fast. But no, it's entirely possible, as you saw. Okay, so we were on the grid. I wanted to show. Okay, we saw what we can do with a ROI and multi-ROI. There's a ton of other stuff that you can do, like on a ROI, for example. Okay, this ROI. Let's say that I convert my multi-ROI as one ROI. I add one. Well, okay, I will kill a couple of objects that are taking too much space in my space. I will make a ROI, which is the. I still have it. I think. Yeah, the mask. I will remove this one. No.
So I was wondering if this data set is good for histographic segmentation,
Not a bad idea.
which is also a very nice demonstration.
Yeah, it's a good demonstration. Okay. And it's related to okay. 15 years ago, it was fashionable to do isosurface based on multi-dimensional data set. Okay, so you would use the co-occurrence of tone of gray and Sobel for the same voxel to segment and generate isosurface. But it's also a tool that is interesting to understand your data set, in fact. So I will show what is what we call histographic segmentation. It can be used to initialize a watershed, but it also can be used to understand a bit more your data when it's well behaved. Also, it's I started, so I use the fiber and the Sobel 3D of the fiber, but I could use any other data set. Let's say that you have SC and BSC or different signal. You can do the co-histogram and see how they correlate together and segment in the histographic space of that data set. So it's a good idea, Anton. Thank you very much. So I will do, let's say even that, 512 bin, compute that. It will take a minute or so. So now we need to compute the Sobel 3D, which is a bit long. Oh, it's a laptop, so it's not super fast. And it will create the co-occurrence histogram of Sobel intensity against tone of gray intensity. We'll see fancy stuff on it, and it will the picture will help us introspect how the edge are related to the tone of gray, in fact. So what tone of gray are in the edge and how the space is partitioned. This particular data set is very simple, so we understand quite well what we see. And we'll see a couple of arcs on screen that on the histogram that represent the transition between different, from the matrix to the fiber. What are the Sobel that you cross in between? If we add multiple classes or multiple tone of gray that are well defined, not too noisy and all that we would see multiple arcs where, like the one we're showing here on screen. Well, sorry, this happened. It's this. Okay, so now you see the histogram, the co-histogram. In the x-axis is the tone of gray. In the y-axis is the Sobel equivalent for each of the voxels. So now we see there's value, the matrix and the fiber, and this is the transition between them. And there's a little spot there, and those also that are quite funny to understand. So with that, okay, and I will switch so that I don't see this, just to simplify my view and not have a ton of stuff in front of me. So I will be on the original plane, and I will paint. Let's say that I'm happy. I want to see two class. Okay, what strange color. Okay, so yellow, it's not much better, but anyway. So and red. Okay. So now I'm able to paint in the histographic space and see where those points exist in real space. So I go there and I paint in the histographic space in red. Where are those? Okay, whoops, there's a glitch there. I had the same issue earlier. Sorry about that. Just a second, I need to do. Maybe this will help. Yeah, okay. So now I'm on the good path. Sorry about that. There's a kind of glitch. So these co-occurrences are those voxels. But even funnier, I can do it in the real space. So I can paint here, okay? Move, but maybe it won't. and it has selected the equivalent. On clicking, I selected the grain that are in that space that have the co-occurrence. It draw them here, and it draw all the other one with the same co-occurrence. Okay, so I'm able with that. In fact, just in that space, I could do a k-mean clustering in the histographic domain, and it would do the equivalent of a watershed here. Or I could use this. Okay, now I have seeds in almost each of those guys. Okay, and I could grow them. I can even dilate so to make them more complete. And I could draw more so that there are less holes and stuff like that. Okay, so that it's more complete in the histographic domain. Well, I went too far. I will remove the frontier. So it will remove point here. And the frontier are here, you know, these are the frontier. And I will paint the matrix. This is easier, and I'll paint like that, and much stuff up here. And now I can do a watershed with that. So it's a way, when it's well behaved and you have good data set, it's a way to generate good seeds for your data set. Because you're looking, you know that the edges are on the arc anyway, and these are the no place. So in fact, I should have before, or well, someone could say that I should remove those points here before doing the segmentation, so that I have nothing in the transient region between the two media, you know. And here I could do it, or I could just start with that and do a k-mean or a mean shift clustering. Where is it? Start, and I want 2. Okay, so, and I can also, funny thing is that I can threshold in the histogram space. So I don't want to see the small occurrence, the outlier. I can remove them and just do the clustering in the histographic space of value that are more than X count, a count of X or something like that. And as I said, in fact, it's a fun tool to know if you have value added when you take 2 signals. Because if it's a straight line, well, it means that there's no value having 2 signals. Yes? I don't understand really what. Yeah. Yeah.
And then you see where you want to press and then you go back to the.
Yeah. Yes.
Is there a way that the program can automatically?
Yeah, well, that's exactly what I'm doing now. I'm doing the separation based on the k-mean clustering on the histogram. Is it exact? Does it answer your question? I don't use the seeds. Now I'm cutting it like, well, it didn't work there. Sometimes it works. It's funny. But oh yeah, because I have the exterior. But if I didn't have the exterior, the k-mean would have separated perfectly for you. But this, when your data is so well behaved, everything is, you're happy in life, because it's very unusual. So the question was automatic clustering, exactly what I'm showing, but in real life, in real space, with real data, and you're pushing the instrument always at the limit, well, it's not so useful. I find it not so good to generate segmentation, but more to understand the relation between data. You put, like, you have 2 energy, you put them in the histogram, you see where, and this tells you something. You see clusters, it means something. If you see a straight line, it means there's no value for your multiple net. So it's a good tool to introspect data, like, and visually click, what is that feature? Where in my histogram is that B feature, you know? Because here I've put Sobel, but I've put anything, any other type of data set. You know, could have been, like I said, the backscatter plus the secondary electron. Could have been like channel 1, channel 2 of a confocal. Could have been multiple energy. Could have been anything. But you just look at 2 at the same time. I don't have a tool to do it with 3, but it could have been informative or useful. So yeah.
So that means that you don't have a kind of or
You do that in another way. In fact, if you want, you would like to do a PCA on multiple data set. Yeah, well, this you could do it on the Python console directly, because okay, for cheater, okay, you think your software is not enough, okay, and you don't like it, well, yeah, maybe, huh? So I open a console, a Python console, okay. I don't show that to people that are, let's say, biologists, and they don't do coding. Okay, this is for people that want to get their hand dirty, let's say. So you can go and drag and drop the data set. Now I have a data set, and I can get the ND array directly. So whoops, I did a typo, sorry. So sorry, I will enhance the font, it will help. And I'm super good at making typo. So now I have the matrix, and if I wish, I can modify it. You know, I can say the matrix, I don't remember, let's say, whoop, not a good keyboard. Whoop. Whoop. Oh, yeah. No. Yeah, sorry. It's not my classical keyboard mapping. No. Okay, I'll switch to English. Okay. So I can say out of 2, I don't remember the syntax. I think it's like that, like that, for 0. And now my data set is carroted. Okay, and I can do anything with it. So if you want to do a PCA, you extract, you zip, you do PCA, create a new data set.
your object is updated as you value. And to follow up on this, if you want to execute some kind of small script, like from an event,
there's tons of stuff like script runner to run script with variable and all that. You can easily develop plugin, action item, menu item, and all that. It's all open, and there's tons of ways to do it. You can do it on the console. You can run a script. You can do. I can go further than that. And let's say that I will show that it's a bit, you know, some people have kids, I suppose, and some people want to teach kids how to program. They teach them Scratch, okay? And we have Scratch interface for the full software. You could rewrite Dragonfly in Scratch if you wish, but it would be like kind of crazy. But let's say that you want to do batching, okay? So for each folder, I want to subfolder, make the path, ask question, blah, blah. For each of them, I will load the channel, apply the function, and everything is accessible. Everything. Because our software is auto-introspecting. We generate macro as much when we run the code. And in fact, it's possible because we analyze dynamically with the IAST. It's a package to analyze the code. We analyze the code dynamically, and we propose all the code that you have seen is accessible in those stuff. So here, this is a method call for a ROI. Well, there's kind of, yeah, there's some code that you can run on this object, but you have multiple object model and all that. So it's highly configurable, easy to understand. No, not easy to understand, but expandable. But you know, Scratch, what's cool with Scratch is when you do a macro like that, everything is typed, so you cannot put blocks that are not coming together. So it's kind of, you have some parachute with you, or a chute. I don't know how you say that in English, but it's very useful. It's a bit advanced though. But so you can do, and in the Scratch, you can write Python also. So you could have a piece of Python that calls SciPy to do your stuff, load all the batch, all the directory in your hard drive, and do an application, do a segmentation with a neural network, output it as a segmentation, do it, dump it in a file. This is all possible. Of course, we have multiple examples, and also we have an extensive documentation on the object model and all that on the website. It's, I suppose, close to thousands of pages of documentation, because I didn't say it, but we've been coding that software for 18 years. And like I said, there's 3.5 million lines of code. So It's not super well documented because we're coder, and that's one thing that coder don't like to do. But we try to do our best to be helpful for the community.
You could demonstrate where the help file information is.
Oh yeah, that's a good idea. So there's a help file that I don't read, but there's a help file online, and it's a web-based one. Okay. Oh, it's not shared. Sorry, I will share the full screen now instead of sharing the screen. This is the screen. Screen. Okay. So this is the documentation for the user. Okay, but we have other documentation for the developer. So this is all the functions on the software are documented with reference when we can, and the name of the algorithm so that you can reference it and all that. Some of them are not referenced. On our website, we have the developer documentation, which is another style of documentation, and it's not exactly for the same people. It's in resource developer documentation. And if you go to the latest release, well, we have a Sphinx page with the object model, how to do plugins, how to connect with PyCharm. You can put breakpoint in our own code to follow it, to know what we do and all that. But I will show you another way. So the object model is quite extensive. And if you look at the graph of it, well, we have a couple, it's truncated. Well, okay, we have a couple of objects, and each of them has documentation and tons of method. It's an object model base. Our company is named The Object because I am an expert in small talk from the 80s. So I'm a purist, like this guy is irreligious for me. Yeah. So another way to, I was about to say another way to see what's happening and use code is when, like I said, when we use the software, we wrote code on the fly, okay? And it's the action log viewer that will give you access to that code. If the resolution is not super good, but this is what we have done. And these are the calls that were done on each of the objects, okay? So it's the code that was run. It's all the macro and all macro compliant and all the bugs, the origin, the click and all that, everything is written. So everything is open for you. You can copy that, run in a script, and it will work, okay? Yes, it's a Python library, and it's a Python library that auto-introspect itself when you're running. So it's right. Yeah. Yeah, and this, it's true. The macro can be played outside of Dragonfly. So you can batch it, you can put it on a cluster or something like that. Because in the next release, we have HPC capacity and we distribute on multiple machines. So you can run your code like that. So all of that is UI-less. Okay, so it means, in fact, that all the code that can be like that is are on the plugin side are class method or object method. It's a subtlety, but anyway, it's already done, and the code is open. 95% of the code is open, so you can look at what we do. You want to do something similar, you just copy our stuff, modify it, name it otherwise, publish it, whatever, we don't care. Okay, we want people to code, and it's we're a bit sorry that there's not so much people coding, but we have people coding in the room that are doing stuff, cool stuff that I didn't even know that people were doing, and maybe even more advanced or cool stuff that we're doing ourselves. So that it's like making a virus and it catches everybody. That's what we want to do.
Nicolas, I think unfortunately time flies. We're reaching the end of this session. So maybe just for everybody here and online, if you are not able to attend all sessions, all will be made available on YouTube later. And we're hoping to get to some other important topics, such as the Puma plugin, for example.
Yeah.
And there's some other interesting things that we'll get to tomorrow. So thanks for joining us. I don't know if you want to say something about the other topics we will touch on tomorrow.
Yeah, well, we will do deep learning tomorrow. So the segmentation wizard and the deep learning tool, and also machine learning. But what you want to do is segmentation wizard. Yesterday, someone came and said, my data set, I'm not able to segment it. It was difficult. It was a phase contrast of related something, and I was able in like 15 minutes to segment it, and it was almost right. I generated it was not possible. So segmentation for you users as a tool. Segmentation is the big bottleneck on your work. You need to do it properly. Deep learning is so awesome now to do segmentation. It worked for real. And the next release even better because we have calibration for segmentation for neural network, and it make them more generic, and it has a lot of impact. Also in the next release, we'll be able to do distributed inference also on multiple machines. So it will be possible to do timely usage of real 3D neural network that takes a lot of time to infer, but give like marvelous result. It's all possible now and soon. So tomorrow I will cover more advanced segmentation topic. And also I didn't cover what I wanted to cover also today, which was extracting classification of extracting multiple scalar value on multi-ROI, like feature vector for each of the object, and doing classification in that space, which is very important for all of you, I suppose. Round particle, cubic particle, and all that. Sometimes you cannot, it's not easy. You may want to do a big feature vector and find ways to separate them, do co-occurrence of orientation, and you see cluster and you separate them by orientation. Often there's preferred orientation. I wanted to show something. I can show it very fast because I'm not able to shut up. Sorry. So I will just import another data set, which is carbide. And here you have full of stuff. And this, I will show it tomorrow again, because it's a cool, super cool data set. It comes from Zeiss again. It's a nickel carbide. And this is one of the phase with fractal surface, super cool. But you can see that, in fact, if you look at the data in 2D, you see that there's a lot happening there. There's small, there's 3-4 phase and very small, like spike or needle, and we managed to segment them without deep learning at that time. It's an old data set, but now you can combine all those rendering and see where are the spike that touch the surface, those that are not, what are the preferred orientation of those that touch the surface or the other one, and all that, to classification of your blobs or whatever it is that. Okay, so tomorrow I will show you how to play with the object analysis, which is our classifier of feature vector of multi-ROI, and I gave you a preview. In the next version, we have something more generic that is multi-object. You can do classification of, let's say, how many cookie, what is the standard deviation of chocolate chip in my cookie, in my box of cookie, in my bag of cookie, or the truck of cookie. So at that each level, meta-analysis, which is kind of cool. Okay, so see you tomorrow if you're there. Have a good night, and I hope I was not too annoying for you. Thank you very much.
Thank you, everyone. Bye-bye.